So, implementation of stacks. So, in how many ways can we implement the stacks? Again, in linked list, you are trying to create a node structure, and you used to have like this, or you have one node. If it's a single linked list like this, if double linked list, so you are trying to create a node structure. You are using a structure to create a node. Then you are defining the variables and you have done the implementation. In the same way, to implement the concepts of stack, we have multiple ways of doing it. One, using array based implementation. How array can be used? We will see that how array can be used to implement the stack concept. The other one is dynamic array based implementation, and the last one is linked list implementation. So, any of these three can be used for implementing stack concept. But again, every one of them have their own challenges, pros and cons. So, it depends on the context which one to use, right. So, let us try to explore the first one, that is array implementation. If I write int a of 5, it means I am creating an array like this, okay, 10, 20, 30, 40 and 50. I am declaring a variable int a of 5. I can insert elements like this 0, 1, 2, 3, 4. We can call this as a stack. You can assume this as a stack. How? See, you are inserting an element that is at 10. So, this is, you maintain a pointer top. You are inserting second element, you put 20 here, then your top will become this. When you are inserting third element 30, this will become your top. So, when you want to delete an element, just you move your top to this, that is it. You move your top to 20, right. Okay. So, you are moving your top to 20. Though the element 30 exists in the array, when you are doing pop operation, you are rolling back your top from 30 to 20. Why? Top is a pointer which points to the topmost element of the stack. It points to the topmost element of the stack. So, when my top is pointing to number 20, it means that means my stack is only two elements, 10 and 20, that is it. So, when you want to insert new element, increment top goes to here, let that element be 40. So, this 30 will be erased and 40 will come here. That old 30 remains at the same location, but we do not have any problem. Why? Because I am using a top pointer which is moving up and down. That will take care of the operations push and pop. Okay? It will take care of the operations of push and pop, right. Right. So, let us see what does it says. So, you can implement stack using an array. In the array, we add elements from left to right. Yes, we add elements from left to right, and use a variable to keep track of the index. Just use a variable top, that is it. That itself is the array implementation. So, how to do the push operation? What is the logic for push operation? You are inserting an element x, right. So, where is your top now? If the array is empty, assume this is my array A, it is empty currently, there are no elements. When it is empty, my top value will be -1, when it is empty. So, when I want to do push operation, simply that array of top, okay, array of plus top, you can do plus top is equal to x. So, what was top value? Top value was -1. Now, when I do plus, it becomes 0, right. So, where is there I am putting x, maybe I am pushing 10, so 10 comes here. Now, my top value changed to, see, my top value became 0 now. Again you call push of 20. So, again a of plus top, so increment to top becomes 1, then at 1, then at location 1 you insert the next number 20. So, 20 comes here and here is my top. If you are doing pop operation, what you have to do? Which element you have to delete? Okay, this is about push operation. This is very clear, simple. What I am doing? I am simply a of plus top, I am doing it. A of plus top, I am doing it. When I want to implement pop operation, when I want to delete an element, okay, simply do this, do top minus. Okay, do top minus. So, your top will come here, it will come here. That is it. the 20 remains there, but no problem to me. Why? My top is 0 now. My top is 0. After deleting an element, again if you are doing push of 30, what is logic of push of 30? A of plus top is equal to 30. So what is top value? 0. Plus top means 1. Plus top means 1. At this location 1, put 30. Where is the index? See, this is index 0, this is 1. In this location 1, put 30. So 30 comes here. That old 20 will be erased. So this is the implementation of stack using an array concept. Okay, you can use array concept to implement it using you can use this array to implement the concept of stacks. Okay, we will see the code. We will try to write a program and execute and see it. Okay, but one drawback is there with this array implementation. What is the drawback? Again, the drawback of arrays compared to linked list. I have to define something 100 like this beforehand only. It means maximum I can insert 100 elements into the stack. I cannot extend it. That is the drawback of the array implementation, right? We can only insert elements only up to 100 elements. So we are fixing the size of the array stack. We are limiting the size of the stack. It is not expandable. It is not dynamic in nature. It can only take 100 elements. Why? I am using array implementation, and we know array we have to definitely give this size. Without giving size, you cannot declare an array. You definitely have to tell how many elements, how much memory should I allocate, that you have to mention in the program. That is the drawback here. Okay, so the array storing the stack elements may become full. After some times it may become full. Then I cannot insert new elements. That's the problem, right? So this is the array implementation. Let us see the logic of inserting elements. Again, I have just written code here, but just we will traverse the code, try to understand the logic. Okay, see, I am creating a stack. I am creating an array by name int s of 100 elements, and I am putting my top value equal to -1 initially. Why? The stack is empty. Okay, I created an array s of 100, and I am defining top value as -1, because initially top should be at -1. Now I have to do push operation. I have to insert a new element int x. What is the logic here? Check if top is greater than or equal to n minus 1. It means n is 100 here. So what is this check required? Why is it required? In the stack, in the array, if all the elements are filled, my top will be here. So top, if top becomes n minus 1, the stack overflow. You have to say stack overflow. Means the stack is full. I cannot insert elements. Otherwise, what I have to do? See, you can write like this: top plus plus, and s of top is equal to x. Or else in a single statement, like I wrote before, you can still do that. You can write s of plus top is equal to x. That is the only statement. So this will insert the element, and also it is incrementing top value. Top value from -1 came to 0 now. What is the meaning of top? Top is a pointer which will point to the topmost element, or the till what extent that the elements are filled. It will be pointing there, that location. So this is the logic of push operation, okay, on the stacks. Next one, pop operation. Okay, what is pop? Pop means I have to delete the topmost element. If again in the array implementation part, if this you have a small array with you, you have some elements 10, 20, 30 and 40 only assume. Here is my top. So index 0, 1, 2, 3, 4, 5. Okay, this is the name of the array. Pop means I have to delete the topmost element. What is the topmost element? 40, because top is pointing to 40. Pop means just make this as your top, that's it. You cannot delete. You already know that in array implementation we cannot delete an element, you cannot delete a node. Okay, so just to make the pop operation is just to make top minus minus. Just write top minus minus. But before that, before I delete that element, I will again check if top is less than or equal to -1. Okay, I will check if top is less than or equal to -1. Why? If top is equal to -1, what does it indicate? It means the stack is empty. Top pointing to -1 means stack is empty. right? So that's the reason when you do this, this check top less than or equal to -1 means you can say stack underflow. It means you cannot delete elements. There are no elements in the stack, or otherwise which element you are deleting, that originally it is at here, no, original top was at 40. So the popped element is stack of top, that is stack of 40. Again, top means again it will maintain a pointer, that index top contains only the index, not the value. Okay, so that element you can display 40 and do just one operation, top minus minus. So what will this do, top minus minus? Okay, this top minus minus will bring top to this location. That's it. The element 40 may remain there. It's not a problem for us. Why? We are worried, we are taking care only about this top pointer. That is itself enough. That will tell us that how many elements are there in the stack. Okay. Then the display operation, you want to print the elements of the stack. You want to print the elements of the stack. So how do you do? I equal to top, that is I is equal to, in this case I is at 2, then I greater than or equal to 0, I minus minus. Why? When you print in reverse order. That's what stack is, no? When you insert 10 and when you insert 20 and then 30, in which order can you take out the elements? You can take 30, then 20, then 10 only. That's why you have to write a logic like this in for loop. For I is equal to top, I greater than or equal to 0, I minus minus, just print S of I. S of I means S of 2, 30, then I minus minus, S of 1, 20, I minus minus, S of 0, 10. So this way you can get print the elements of the stack. So this is the array implementation of stack data structure. We need to focus more on only two operations. One is push, other is pop. So here logic is simple, that stack of plus plus top is equal to the new value which you are inserting, and in delete, in pop, you have to just make top minus minus. That's it. So this will insert the element, this will delete the, move the top point. It will not delete, but it will move the top pointer from the one position to the other position, previous position. This is about the array implementation in stacks. But what are the drawbacks here? What is the drawback? The maximum size of the stack must be first defined. It cannot be changed. Once we define the size of the stack, we cannot change it. That is fixed. That is even the drawback of array concept. Okay, we cannot continue that, right? So trying to push a new element into the full stack causes implementation specific exception. Means you gave already A of 100, you already inserted 100 elements into the stack, but you want to insert a new element at 101. Will that accept? No, it cannot take. It will give some exceptions. You are going out of bound, no, array out of bound exception or something of that kind, or index does not exist, index error it may throw, right? So that is the drawback of array implementation. So for that we have to find out for some alternatives, what are the different ways of doing the array implementation. The next one is dynamic array implementation. The second one is style of implementing stack is dynamic array. Okay.